is talking about slope. Okay, when you're dealing with slope, you guys remember being exposed to this before? The slope of a line is designated as the ratio of the rise of a graph to the run of that graph. And so in a set of coordinates, if you're looking at the slope of a line, your rise is the change in which coordinate? As you move up, it changes y. Okay, so this symbol isn't a triangle, it's a delta symbol. And it's got kind of a triangle with a little thicker shaded side. That just means change in. So change in y over the run. The run is the change in x. And so there's a formula that you can use, or an equation, to identify slope if you're talking about finding a slope between 2 points. So if you have the point x1, y1, and a second point x2, y2, where your subscripts are just used to distinguish the sets of points. The slope is equal to the difference of the y's. So y2 minus y1 over the difference of the corresponding x's. So if you start with y2, you would have to start with the corresponding x, x2. And so that would be your slope equation. Okay? And the letter that's used to represent slope is a lowercase m. Okay, now, again, it doesn't matter whether you start with y1 or y2. If you had started with y1, the difference of y's over the difference of x's would just need to be switched as well. So either of these forms would work okay when you're talking about the slopes. Okay. As far as just looking at general graphs or general slopes, when your graph goes up and to the right, your slope is a positive rise and a positive run. So a positive divided by a positive gives you a positive slope. If your graph goes down and to the right, here you have a rise that's negative and a run that's positive. So your overall slope is going to be a negative divided by a positive. So you'll have an overall negative slope if your graph moves down. If your graph is horizontal, here your rise between any 2 points, your rise is 0, and your run is either a positive or negative. If you take 0 and divide by a positive or negative number, what do you get? 0. So a horizontal line has a slope of 0. And then finally, the last one that you would need to distinguish would be a vertical line. Here your rise is positive or negative. Your run is 0. So what's a positive or negative number divided by 0? You can't do it, right? So that would give you an undefined slope. Okay. So just as far as general tendencies go, up and to the right is positive slope, down and to the right is a negative slope, horizontal line is a slope of 0, a vertical line is an undefined slope. Okay. If you're writing your equations for these, this vertical line, what variable never changes in a vertical line? The x-coordinate or the y-coordinate? X-coordinate, right? So this is always going to be x is equal to, and I'll just use a to represent some number. So a vertical line has an equation x equals a. What about this horizontal line? Which coordinate never changes in a horizontal line? No matter what x-coordinate you have, the y's always stay the same. So a horizontal line has an equation of y equals b. The reason I choose b for this is that b is the y-intercept. And so a horizontal line can still be expressed in the slope-intercept form or as a linear equation. Okay, because is a horizontal line a function? Does it pass that vertical line test? There's no place that you can draw a vertical line that would pass this horizontal line in any additional points. So a horizontal line is a function. Is a vertical line a function? No, by itself it doesn't pass the vertical line test. So these would not be considered functions if we kind of tie into what we talked about last section. Okay, so be aware of that. And then either the positive and negatives, these will always be able to be expressed in slope-intercept form, y equals mx plus b. Okay, they're linear equations of that form. Here, though, the m, the slope value, will be positive. Here, the slope will be a negative if it's pointing down. Okay, so let's say we wanted to find the slope between 2 points on a graph. And so let's say we take the point -1, 4, and we take the point -3, or actually 3, 2. Okay, first of all, when we're looking at this equation, are we expecting the slope to be positive or negative? It goes down and to the right, so we expect it to be negative. So our slope, general tendency-wise, should be negative. It's a good idea just to anticipate that, because now when you do your calculations, you know that you need a negative number. If you get something other than negative, you know you've done something wrong. Okay, so if we take our slope equation, which is m is equal to the difference of y's over the difference of the corresponding x's, okay, what values can we plug in for these? What can we substitute for y1? Doesn't matter. Either 4 or 2, doesn't matter which one. Let's say we start with 4. If we take 4 minus the other y coordinate, 2, when we divide by, do we now, can we pick either the 3 or the -1? Which one do we need to start with? No, we want the point, that x coordinate that corresponds to the y of 4. So we have to take -1 minus 3. And so when we simplify this, 4 minus 2 is 2. -1 minus 3 is -4. And so completely simplified, this becomes -1/2. So the slope between these 2 points is -1/2. Okay, so one way to solve it is to calculate. Calculate using m is equal to the difference of y's over the difference of x's. And now, there's some other ways that we can go about solving this. Anybody know another way that you can identify this slope? Jack? Yeah. One of the easier ways is just to use counting. And in this case, you're using m is equal to the rise over the run, right? Or the change in y and over the change in x. And if you're going to count this, you can just start at either point. It doesn't matter whether you work right to left to right, up or down. And if you just go from one point to the other. So let's say we start at this, just moving left to right. Here, to get from one point to the next, here we went down 2. And then we went to the right 4, so plus 4. So what is -2 over 4? It still winds up giving us the same value, -1/2. So anytime that you can, and this is especially true on standardized tests and for SAT, if you're looking at the slope, it's usually going to be in a window that's easy to count. Right? These numbers are relatively easy to count, so just count it. Down 2 over 4, simplify your fraction, and you have your answer.